All right. Well, it's my great pleasure this morning to welcome Dr. Greg Maguire all the way from San Diego, California. He's a real expert in stem cell release molecules and how they can provide some incredible efficacy in skin repair and skin rejuvenation. Just as a brief introduction to Dr. Maguire, he's a former professor of neuroscience at the University of California, San Diego, a Fulbright Fogarty Fellow of the National Institute of Health in the US. He's a scientist, an innovator, a teacher, a healthcare professional, and has over 100 publications and numerous patents. His book, Adult Stem Cell Release Molecule, A Paradigm Shift to Systems Therapeutics, was very well received. It was published by Nova Science Publishers in New York in 2018. He's really transforming the world of stem cells. He's the founder of Neogenesis, a skincare therapeutic company based in San Diego, California. And we are delighted that we are currently this product's been available in Australia for salons and clinics to benefit from their use. Okay, so welcome, Dr. Maguire. Thank you for sharing your incredible knowledge. We're so excited to have you today. So we know that stem cells in skincare is nothing new. Whether they're derived from plants or from human tissue, they have been used extensively. However, from a scientific perspective, there appears to be reservation as to whether they actually work. As we know, there are several challenges within their use. So my first question to you this morning is, as an academic authority in this area, can you please explain to us stem cell release molecules? What is unique about them and different, and how can they benefit work within a skincare product?
Tina, thank you. Good to be with you. Yeah, the stem cell release molecules really surprised us back in the 90s, how powerful they were. And what I mean is stem cells were thought of cells that could multiply themselves and then differentiate, turn into mature cells. Brain cells, kidney cells, skin cells. But what we were beginning to find out really in the 90s, quite remarkably, is that the adult stem cells that reside in our tissues do most of the maintenance and repair through the release of a bunch of different molecules. And I happened to discover this in my laboratory when I was working with genetically modified stem cells. The control stem cells releasing all the molecules were actually working better than genetically modified cells. So it dawned on me that these cells were releasing a plethora, many different types of molecules. I later wrote a paper about it, stem cell therapy without the cells, meaning the molecules do much of the work most of the time. If
so
tissue is highly...
Which molecules are activated?
There'll be mainly a lot of different types of proteins. So there are proteins that direct the skin to repair itself. There are the actual building blocks for the skin that are released, collagens, procollagens, laminins, proteins that bind the laminin and the collagen. So, and then there's molecules to instruct those building block molecules about how to come together to repair the skin. Then there's a bunch of molecules that can either induce inflammation or reduce inflammation and put the whole system into a state of pro-repair, anti-inflammatory pro-repair. So there's a lot of molecules available from the stem cells, as long as you correctly choose the stem cell types to induce the effect that you want to see, namely maintenance and repair anti-inflammatory aspects of the molecules.
Well, the issue of inflammation is very, very important at this stage, especially with COVID and long-haul COVID. So we're seeing a lot of inflammation, systemic inflammation, as well as in the skin as well. So from that point of view, can these molecules can they switch off inflammation in the skin? And also the other area that we're very interested in, what about their activity with immune cells like the T cells? How can they work?
This is very important. Yes, they can. So the molecules from the cell types that we use in the skin will reduce inflammation, put the system into a state of pro-repair. They do this by acting upon both the innate and the adaptive immune system. So macrophages, part of the innate immune system, the instant attack system of pathogens, can be in an M1 or an M2 state. And M1 is inflammatory and it's going to attack pathogens. M2 is more of an anti-inflammatory pro-repair state. The molecules will shift from M1 to M2, anti-inflammatory pro-repair. Same with T cells. T cells, when you have damaged tissue, pathogens, you can activate the T cells, Th1s, Th17s, pro-inflammatory T cells. The molecules from the stem cells in the skin can shift that to the Tregs and reduce inflammation, put the skin system into a state of pro-repair. Likewise, also induced by these vaccines, induce a very powerful innate and adaptive immune response, including the production.
Very valuable. Yeah, that's very, very valuable.
It can be a supernormal response. The vaccine can induce more of an immune response than does the pathogen, that is the SARS-CoV-2 virus. So you get an induction of innate and adaptive immune responses. Part of the adaptive immune response will be antibodies. And part of that response will be autoantibodies. And some of us make too many and too strong autoantibodies, and you induce an autoimmunity. And the autoantibodies can be very, very damaging after the vaccine. So these molecules have been shown to reduce the effects of autoantibodies and reduce vaccine-induced autoimmune disease. So you've got cytokines, you've got cells inducing inflammation, you've also got these autoantibodies causing problems. And these molecules will shift all three of those mechanisms towards anti-inflammatory state.
Just in that vein that you're talking about there, the issue of their efficacy, is it restricted from epidermal penetration? Do we need to break the epidermis to get the molecules in? I'm just looking at the penetration and capability of these molecules to be activated. How is it best to prepare the skin for receiving them?
Yeah, we were surprised long ago. We were first working with compromised skin where the barrier was gone, damaged skin where barrier was gone, and molecules were working great to reduce inflammation and heal those wounds. Then we noticed the surrounding skin was also looking better. If you were dealing with an aged person and these molecules were being applied daily, we were noticing surrounding skin was actually looking better. And that was quite surprising with these big proteins. And we didn't know so much about the exosomes, those liposome-like particles back then. So then we began to investigate, can these molecules actually penetrate intact skin? And indeed they can. They're the exosomes that contain the molecules, or most of the molecules are contained in exosomes, really penetrate a lot of different barriers, including the epidermis. And so they will. That's not to say if you use enhancement techniques, you can have better penetration.
Skin needling.
Yeah. So you can do things, even microneedling, where you put channels into the skin can bring in more molecules. We've shown that years ago. But even with intact barrier, you can get a lot of these molecules through the barrier into the deeper layers of the skin.
What about immune compromised skin? Would that make penetration better if the skin itself has been compromised?
Yeah, I mean, it's really true. If the skin is compromised in some way, then you're going to have a better chance of these molecules, especially the molecules contained in the exosomes. So a lot of the molecules are contained in the exosomes, but there are also some soluble molecules not contained in the exosomes. And the technology works best if you have the exosomes with the soluble molecules, and those will better penetrate and somehow barrier reduced skin.
Okay. Now, I just want to ask you about the patented S2RM technology. How does it differ from other stem cell technologies?
Yeah, the key to our technology, to the patents, and to our intellectual assets that aren't patented is proper choice cells. So you've got to be really careful. Under the rubric mesenchymal stem cell are actually a lot of different types of stem cells. So if you choose a mesenchymal stem cell from, say, the bone marrow, it's going to be different, very different from a mesenchymal stem cell chosen from the skin. Bone marrow, for example, is a recirculation site for cancer cells, inflammatory T cells, and they can induce in the mesenchymal stem cells in bone marrow a pro-inflammatory mesenchymal stem cell, even one with pro-oncogenic signals. So those are very, very different. Even if the genotype, the genetics are the same, the fact that the mesenchymal stem cell sits in a different environment means it's going to have a very different phenotype, a very different characteristic. And so even in the skin, you have to be very careful to choose within the skin very specific phenotypes of these cells. And then each phenotype, since we use more than one stem cell type, you've got to choose each of the stem cell types correctly and in the right combination to bring about the desired effect that you want. And so that's what the patents are all about. Choosing the right cells from the right tissue, the right phenotype within the tissue, and the right combinations of the stem cell types.
Basically, the patent has identified the pathway through which you get the most efficacy and also the safest delivery, and that then is the reason for the patent, because it's identified the pathway and then secures that. So basically, what we're seeing is that the Neogenesis products are based on this S2RM patented technology, and this gives it the assurance, gives the practitioner the assurance that the molecules are safe and that also they're efficacious. So I think that's very, very, very important, especially as we're moving into more compromised skin with COVID. Practitioners and clinicians want to know that they have an instrument, they have some tools that can really support both the bringing down the inflammation issues that they're encountering, as well as improving the immune system cells that will allow the T cells to bring about repair where it's needed. So look, I thank you so much for this interview. It's been a great pleasure having you, Greg, and we just want to thank you for your dedication to science and for developing a truly novel product that will bring some good answers and support to skin therapists as well as clinicians that really are looking at helping consumers not only repair damaged skin, but also in the area of skin rejuvenation. So it's a pleasure interviewing you, and thank you so much.